Hello Guntur and everyone. My name is Kenneth Pratama Widian, and in this video, I will present an analysis of data on CO2 emissions per capita from 20 Asian and European countries from the year 2000 to 2020 using the R programming language. The purpose of this experiment is to implement the fundamentals of R programming by prioritizing data analysis using real data. In this case, CO2 emissions per capita in Asian and European countries from the year 2000 to 2020. The data used is sourced from gapminder.org, which consists of a list of 195 countries and CO2 emission data from the years 1880 to 2022. However, this experiment only used CO2 emission data from 20 countries from the year 2000 to 2020. The country name data is the character type, whilst the emission data from 2000 to 2020 is the numeric type. The first data analysis process is importing the dataset that has previously been explained. The dataset is in the form of a CSV file in the local directory. The second stage of data analysis is in the form of data cleansing, which aims to eliminate dirty data that is not used in the analysis. This stage is carried out by eliminating CO2 emission data outside the range of the year 2000 to 2020, as well as emission data from countries that are not part of the list of 10 Asian countries or the list of 10 European countries. The next stage is the pre-processing stage, which aims to standardize and prepare the data so that it's easy to process. This stage is done by changing numeric data type to double data type. Furthermore, the addition of the continent column uses the ternary operator, with the condition that if the country column is in Asia_list, then the continent has a value of Asia. If not, then the continent has a value of Europe. Exploratory data analysis to find the average value of CO2 emissions from Asian and European continents was carried out by grouping data by continent. Then, the data in the same group is calculated using the mean function. The second exploratory data analysis in the form of finding changes in CO2 emissions in each country from the year 2000 to 2020 was carried out by reducing the emission value in the year 2020 with the year 2000 and then dividing it by the emission value in the year 2000. Visualization of EDA results of the average value of CO2 emissions from the Asian and European continents using a line chart considering that the data produced in the form of continuous numeric values that can be linked to the lines. One line represents a single continent, which is distinguished by the color. The results of the EDA of changes in CO2 emissions for each country in the year 2000 to 2020 are presented using a bar chart. Negative values indicate that CO2 emissions from the years 2000 to 2020 have decreased, whilst positive value indicates the opposite. The results of the first analysis showed that Europe has a higher average CO2 emissions per capita in 2000 to 2020 than Asia. But Europe's average CO2 emissions per capita has significantly decreased in 2020 in comparison to 2000. On the other hand, Asia's average CO2 emissions per capita in 2020 has increased compared to what it was in 2000. The results of the second analysis showed that CO2 emissions per capita for most countries in Asia have increased, except for Japan and Singapore, whilst it has decreased for most European countries. It can be concluded that most countries in Europe have experienced a significant reduction in the amount of CO2 emissions, which shows a shift towards better conditions, whilst some countries in Asia are unable to reduce the amount of CO2 emissions that exist. Despite this, the average emissions of Asian countries are still lower when compared to European countries. That's all for my presentation. Thank you very much.